Hello, my friends. Recently, I encountered with a very interesting concept, and I decided to share it with you all. It's very amazing one, and to explain it better, let me ask you this question. Imagine we have a jungle, some part of the world, Brazil or in Europe or in Australia, anywhere in the world, doesn't matter. And we have a lot of different vegetation on that jungle. We have trees, we have different type of different type of vegetation covering this jungle. And imagine there is one tree in this jungle that is faded. So how you can figure out which tree is faded without going to that jungle, without knowing what type of trees they are, without knowing anything about the age of the trees, how you can, and without having any tools to measure any quantity for this jungle, how you can figure out which tree is faded. And what this analysis is about is to find the answer to this question. So to be able, as you see here, I have a picture here, and this picture is comprised of different type of raster data. So this raster data, you can find them on USGS Earth Explorer website. You need to have an account with them, and you can go and download the raster data for any part of the world that you are interested to do some analysis. They are free, so you just need to go to USGS website and download the area that you are interested in. But when you this data that I have downloaded already is Landsat data. So Landsat data is comprised of 11 different bands. For this type of analysis that we are doing, you just need band 1 to 7, which I already selected them and brought it to contents menu. Uh, the other bands are thermal bands that doesn't help me for this type of analysis. So uh, to be able to do the analysis of figuring out which vegetation is faded, first step is to select all these 7 bands here, and then go to imagery. Under process, there is something called composite. If you push this button, you're gonna get what I got here. So let me turn off these raster files since we don't need them anymore. Actually, I can delete them, but that's fine now. I'll keep them now. So this composite file, put together all these 7 different raster data. Why they are 7 different raster data? Because the satellite or the airplane, whatever took this image, they use different wavelength of electromagnetic waves to take this picture. For example, they used C-band with wavelengths of 20 centimeter. They got one image. Then they got another image with another wavelength. Then they got another image with another wavelength. So they use a different range of electromagnetic waves to take this picture. And what composite does, put all these together in one picture. And if you go to composite, if you right click on it and you go to symbology, as you see, we brought in 7 different bands, but here we have 3 spots to select what type of color we want these bands to have. For example, if I combine it like 613, it shows in this color. If I combine it in 616, it shows in kind of like purplish color. So there are different ways to combine that. But 2 things that need to have in mind is combination of 4, 3, and 2. It makes it natural color. So if you were on an airplane and you were looking down, passing over this part of the world, which is Houston, Texas, by the way, and you were looking down from windows, that's how the color, natural color that you will see this part of the world. And the combination of 5 and then 4 and then 3 for red, green, and blue, this is called false image combination. And as you see, is covered by a lot of red color. And the interesting thing about the infrared picture like this one is whatever is made of chlorophyll, any type of plant, vegetation, when you make the combination of the colors 5, 4, and 3, it becomes red in the picture. As you see here in this image, everything that is red is some sort of vegetation. If we how we can make sure of that? So it's very easy. We can turn on the base layer map and look down at that. So as you see here we have vegetation. If I zoom here and turn off the world image map, or have that on and turn off composite, you see that everywhere that is green in the real image, if I turn on the composite, it become red. So anything chlorophyll in the combination of 5, 4, and 3, it become red. So that's important to keep in mind. So how we can analyze this and how we can figure out the health of vegetation based on this information so far. So if we go to imagery, if I select the composite and then I go to imagery on the raster function, if I click that, there is NDVI. Technically, what NDVI is, based on this combination of 5, 4, and 3, it comes and analyzes the picture. Every pixel of this image uh, is associated with a number of chlorophyll, and it's gonna go analyze that based on the number that it has. It figure out how healthy that vegetation is. He explained that it combine a raster data set and assign a number to that, NDVI number to that. Whenever the NDVI number is negative, is something that is associated with water. It can be cloud or it can be water body. It can be river. Whenever the NDVI index number is close to zero, it is either rock or soil, and the NDVI that is positive is related to vegetation. And if NDVI number is closer to zero, between 0 to 0.3, these are faded vegetation. And as the NDVI number gets closer and closer to 1, it is a healthier vegetation. What NDVI is, you can read about it online, but it's net difference vegetation index. Uh, you can read about it online, but it's the difference between infrared minus near infrared over infrared plus near infrared. So that's the mathematical concept behind it. But if we do this analysis, we need to select our raster data, which will be our composite data. And as we talk about, band number 4 is the visible band, and band number 5 is infrared band. And when we do this type of analysis, we need to tick this scientific output. And when we create a map, it's produced this map. So in this map, everything that is negative to 0, these are related to water. As we see with blue color here, this is water, this is water, these are all water here and here and here, everywhere. That is blue is water. Close to, it's hard to see, but it's kind of like greenish. Those are close to 0. So wherever is that greenish color is kind of like soil. Because in Houston we don't have that much rock. And yellow and orange, these are the vegetation. For example, let's look at here. Here actually is a good example. Here is yellow, here is orange. And let me turn on the world imagery map. We have this here, the NDVI map. So here it says it was yellow. So it's less healthier compared to here, which is green. And if I turn on this map again, we can see that this is compatible with the real world. Here it looked like a little bit greenish to bluish, so it should be soil. If I turn it off, it's kind of like more soil. Yeah, you can see the soil here and here. So yeah, you can see it here too. So more it gets orange, it's a healthier vegetation. Kind of like goes toward the blue or green, it is, or kind of like between yellow and green. That's where the vegetation is faded. So here we have healthy vegetation here, and here is about to get faded. So let's see how it look like in the real world. Yes, healthy vegetation here, and here is kind of like faded, closer to soil, dead plant. That was a very interesting concept for, and I never thought really it wasn't intuitive that much for me at the beginning that we can use satellite data to figure out the health of plants and vegetation. I hope you enjoyed it as much as I did. Thank you so much. Have a wonderful night.